Hello. Today we'll be going over section 2.2, Graphs of Linear Functions. This section is, in summary, it's pretty much a lot of the concepts you learned about lines in one section. And while I am assuming you've seen them before, this is just to remind you of all of those properties that lines have. To begin, we turn our attention to functions whose graphs are straight lines. Such functions are called linear and can be written in the form f of x equals mx plus b. Definition of a linear function. A linear function f is any function that can be described by f of x equals mx plus b, where m is a slope and b is a y-intercept. The constant b, the y-intercept. So what is a y-intercept? We see here, by our definition, the y-intercept of a graph of f of x equals mx plus b is a point 0, comma b. Remember, your points are always x, comma y. So we're saying that x by default is 0 and y can vary. Now, you see, your y-intercept is always the point that crosses your y-axis. And it can be anywhere along the y-axis. It can be somewhere above the origin where it's positive. It can be on the origin itself. It can be below the origin and have some negative y-intercept. It's all fair as long as it crosses the y-axis. The constant m, that's the slope. We call the change in y the rise and the change in x the run. The ratio rise over run is the same for any 2 points in the line. We call this ratio the slope. The slope describes the slant of a line. The slope of a line is a graph. In the graph is given by rise over run is same as change in y over change in x. I also think of your slope as your steepness, how steep something is. Now you also see, instead of change in y, you'll see a little delta. Same for x. Change in y and change of x. We can also use that Greek letter delta to symbolize that. And it just means a difference in. So yes, subtraction. Let's do a quick example of graphing a line. Example, graph the line containing the points -4, 3 and 2, 5. Remember, we have our x and our y-axis, and that tells us where to plot our x and our y points. So first, let's make this point A. I have point A at -4, so I find -4 along my x-axis, and then 3 along my y. Where they meet, that's my point. So here I have my point A, which is -4, 3. Let's call the other point B. We have 2, -5. Another way I think about it is I find my x coordinate. So here I have 2, and then since it's negative, I'm going to go down 5. It'll bring you to the same point. So that's 2 different ways of graphing a point. So we graphed a line. To graph a line, you just need 2 points. So here I have 2 points. I'm going to go ahead and connect them using a line. So we have it. Now, because lines are never ending, we always draw a little arrow at the end. Let me erase my little tick marks. And there we have it. We have graphed a line using 2 points. Now we talked about slope. There is a formula to help you find your slope. So to find your slope, you may use the slope formula, which is y2 minus y1 divided by x2 minus x1. So what are these small subscripts of 1 and 2? That's just meant to help us keep track of our point 1 and point 2. So if I have my point 1, that's x1, comma y1. And if I have my point 2, to show that my x's and y's are different, I'll write a little 2 subscript. Now, it doesn't matter which one is 0.1 or 0.2 as long as our pairings are the same. So if this is going to be 0.1, then they both should have a 1 little subscript. This can also be 0.1, but make sure they're both 1s. Moving forward, definition of a slope-intercept equation. Slope-intercept equation. The equation y equals mx plus b is called the slope-intercept equation. The slope is m, and the y-intercept is your b, or 0, comma b if you want it as a coordinate point. So for example, find the slope and the y-intercept. So what's very nice about this is your slope is always a number that's next to your x. So we know that's our slope. And our y-intercept is a number that doesn't have an x. So we know that's our b. So we can say that we have a slope of positive 5, and we have a y-intercept of 0, comma, negative 4, or just negative 4. But I think it's a good habit to write as a coordinate point. Now, what's nice about this first example, it's that it's already written in our slope-intercept form, y equals mx plus b. If it's not, like in our next example, all we have to do is solve for y. Or if it's written in function notation, we can just solve for f of x. Next example. Find the slope and the y-intercept of 2x plus 3y equals 8. So here, our hurdle is that it's not in slope-intercept form. So we must solve for y. And we solve for y so that we have it in the form y equals mx plus b. Okay, so let's get y by itself. Let's move the 2x. So minus 2x minus 2x. We're left with 3y equals negative 2x plus 8. Let's divide by a negative 3. Positive 3 to get y by itself. And so that gives us y equals, now remember the 3 divides both the x and the constant. So we have negative 2 over 3x plus 8 over 3. So that our answer would be our y-intercept is negative 2 over 3. Our slope is negative 2 over 3. And our y-intercept is 0, comma 8 over 3, because that's a coordinate point. Moving forward, x-intercepts and y-intercepts. A y-intercept is a point 0, comma b. To find b, let x equal 0 and solve for y. An x-intercept is a point a, comma 0. To find the a, let y equal 0 and solve for x. And this tells you everything, right? So your y-intercept your y-intercept is a point along our y-axis. Our x-intercept is a point along our x-axis, and it can be anywhere along the lines. And there are special points that a line may have. Now here you also have your instructions. To find b, let x equal 0 and solve for y. To find a, let y equal 0 and solve for x. So in other words, let the other letter be 0 and solve for the remaining variable. Okay, example, find the intercepts of 3x plus 2y equals 12 and then graph the line. Have a little grid on the bottom to graph. So let's first find our x-intercept or y-intercept. It doesn't matter which one you find first. So to find your y-intercept, our rule says let x equal 0. So we're going to let x equal 0. So that we have 3, we're going to let x be 0, plus 2y equals 12. Now we're going to go ahead and solve. Now our only letter left over is the y, so let's solve for y. So 3 times 0, that's just 0. We're left with 2y equals 12. Divide by 2, divide by 2. Y is equal to 12 divided by 2, you get 6. So I have a y-intercept of 0, comma 6. And in case you're concerned or forget the order, it's always x comma y. You said x is 0, hence a 0, and you got a y is 6, so our y is 6. Moving forward, to find the x-intercept, we're going to let y equal 0. So let your other letter be 0. Let's plug that in. We have 3x plus 2, and we said y is 0, equals 12. All right, well, anything times 0 is 0. We have 3x equals 12, divide by 3, divide by 3, x equals 4. Starting my coordinate point, x comma 0, our x is 4. My y, well, we said y is 0. We have 4 comma 0. Let's plot these points. So you can think of it as a point, but you also have the answer. Your y-intercept is a point along the y-axis, so we have positive 6. There we go. We put a dot right on the positive 6 number. Next, I have an x-intercept at positive 4. I put a dot right on the 4. And these are my points. So I can go ahead and connect the dots. And we have our line. Pretty cool, right? Moving forward. Graphing using the slope and y-intercept. We saw how it may be possible to graph using intercepts. However, what about the situation where x and y-intercepts are the point 0, 0, right? Because if my x-intercept is at 0 and my y-intercept is at 0, then intercepts would not be the best way to graph because they would just produce a single point. So here's another way to approach graphing. To graph using the slope and the intercept, first you want to make sure that the graph is in slope-intercept form, y equals mx plus b. If not, then solve for y. 2. Plot the y-intercept. This point will be directly on the y-axis. 3. Use the slope using your rise over run. If the slope is not a fraction, write 1 as the denominator. A. Count the units up and down, the rise. Count the units left to right, the run. So let's go ahead and graph these two graphs. So let me write them down right here. Y equals negative 2 over 3 plus 1, and y equals negative 4 over 5x plus 4. Okay, so let's talk about each one of these graphs. We have our slope and we have our y-intercept. So we first want to talk about our y-intercept. It's 1, so that means it's a point 0, comma 1. Next, we want our slope. We have negative 2, 3. Now, I always have students concerned about where the negative goes. It doesn't matter if you attach it to the top or the bottom, it still makes your entire fraction negative. So if you want some instruction, always put it on the top. All right, now this tells you your rise over your run. So your rise means to something that goes, well, how does the sun rise? It goes up and then down, right? So up and down. Your run refers to something that goes left and right. So because we have a negative 2, negative will tell us they're going down. So they're going to go down 2 units. And your run is positive, so you go to the right 3 units. So let's go ahead and graph our first graph. So we have our y-intercept of positive 1, and then we said we're going to go down 2 units and then to the right 3, right? Down to right 3. So we go 1, 2, and to the right 3. 1, 2, 3. So this is my new point to find my slope. So I went down 2 and I went to the right 3. And that produces our desired graph. And now from there we can just go ahead and connect your points. If you miss your points, a very bad trick is you can just make your circle bigger. Right? So there we have our first graph. Now, once you kind of get the hang of it, you don't have to always show that much work. You can just go ahead and label what you need. So we have our y-intercept of 4, right? So y-intercept of 4. And then I have a positive 4 and a positive 5. So I'm going to go to the right 4 and then go down 5. I'm sorry, up 5. And I said that backwards. I need to write rise over run. Rise over your run. So this means I'm going to go up 4 and to the right 5. So I go up 4, 1, 2, 3, 4, and to the right 5. 1, 2, 3, 4, 5. There we go. Let's go ahead and connect these two dots. And you don't have to write that. You can do it in your head, of course. So this is a method of graphing using your slope and your y-intercept. Now, horizontal and vertical lines. Let's read from our notes. The graph of y equals a number, let's say b, y equals b, or f of x equals b, is a horizontal line. So notice I don't have an x. If I ever just have y without the x, we assume it's a horizontal line. Moving forward, is a graph of a constant function with a slope of 0. So horizontal lines have a slope of 0 and they're always y equals a number. Second, the graph x equals a is a vertical line with the x-intercept a, 0. The slope is not defined and the graph is not a function. And it is not the graph of a function. So horizontal lines have a slope of 0, vertical lines do not have a slope. It's undefined. All right, so first example, graph y equals -4. So because we have a y, I know I have a horizontal line. So I know it's a line that goes this way. And it goes from left to right at -4. So we find -4, and from there we want to make sure it goes left and right. So this is our horizontal line at 4. Now here we have a vertical line at 6. So it's a line that goes up and down. So I want to go up and down at +6. Is it here? No, well that's -6. So that's not it. We want a line at +6. So we label 6 and we go ahead and draw our vertical line. And there we have it. Now, if you're ever confused and you can't remember which way is horizontal or vertical, or you can't remember what the rule is, you can go ahead and do a table. So if you do a table, let's do this last example B. Here we're saying my x is always 6. So let's draw some 6's. Now what can y be? We were never told. So we can make y whatever we want. Let's say 0, 1, 2, 3. Now we have points. We have the point 6, 0. We have the point 6, 1, 6, 2, and 6, 3. So let's plot them. We have 6, 0, 6, 1, 6, 2, and 6, 3. And if we connect them, we can see the line we are working with. Same thing for example A. We have x comma y. We're saying y is always 4, negative 4. So what can x be? X can be whatever you want it to be, right? And you can connect your line that way. Okay. Last piece about lines is they have a feature where they can create parallel and perpendicular lines. And this depends solely on the slope. So let's go ahead and talk about parallel lines. Two non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines are parallel. Determine if the graph of y minus 3x equals 1 and 3x plus 2y equals negative 2 are parallel. So for them to be parallel, they must have the same slope. But here, it's kind of hard to be able to compare the two slopes. So let's go ahead and take the time to write them as y equals mx plus b, because this way I can easily pick out our slope. All right, let's go ahead and do that. So for the first one, we have y minus 3x equals 1. Let's solve for y. Let's get y by itself. So we're going to go ahead and add 3, x, and we're left with y equals 3x plus 1. That's my first line. Let's look at my second line. So I have a 3x, that looks promising, but let's get y by itself first. So let's go ahead and move that 3x. So we have 3x plus 2y equals negative 2. Let's go ahead and subtract 3x to both sides. And we're left with 2y equals negative 3x minus 2. Let's go ahead and divide by 2 to get y by itself. The 2 divides the 3 and the 2. And we're left with y equals negative 3 over 2x minus 2 divided by 2 is 1. Okay, now I can easily compare my slopes. And if we look at our slopes, we have 3 and negative 3 over 2. Are they the same? No. So they're not parallel. Why? Because they have different slopes. According to our definition, parallel lines have the same slope. All right, next, perpendicular lines. Two lines are perpendicular if the product of their slope is negative 1, meaning if one line has slope m, the other line perpendicular to it is negative 1 over m. That is, to find the slope of a line to a given line, perpendicular to a given line, we need the reciprocal of the slope and change the sign. Lines are also perpendicular if one of them is vertical and one is horizontal. All right. So we need to look for opposite reciprocals. So opposite means we go from positive to negative or negative to positive. And reciprocals mean if I have A over B, I'm looking for B over A. A reciprocal, right? A flip within the fraction. So same question. Example, determine whether the graphs of 5y equals 4x plus 10 and 4y equals negative 5x plus 4 are perpendicular. So to do so, I need to compare their slopes. To compare their slopes, let's go ahead and solve for y so that I may get the y equals mx plus b form. That slope-intercept form. And we do this so we can check out that slope and then compare. All right, let's go ahead and do so. So our first equation is 5y equals 4x plus 10. So I need to get y by itself. Let's divide by 5. We're left with y is equal to 4 over 5x plus 10. All right, now that second equation, 4y equals negative 5x plus 4. Let's get y by itself. Let's divide by 4. We're left with y equals negative 5 over 4x plus 1. Now let's go ahead and compare the slopes. Is one positive and one negative? Yes. Are they reciprocals? Is one the flip of the other? Yes. So they are opposite reciprocals. So we write these checklists again. So opposite. We see that one is positive and the other one is negative. So they're opposite. And then reciprocals. Are they flips of one another? So I have 4 over 5 for this one. And if I flip it, we're left with 5 over 4, which is this one. So yes, these two slopes are opposite reciprocals, and because of that, we can say they're perpendicular. All right, so this is about a chapter's worth of lines in one section. I hope this was just a refresher and you were able to recall a lot of what you learned about lines. Thank you.